Hi, this is Francis Potter, and with just a quick run through of one way of many of using GitLab to train and run a machine learning model. So this is a little project called CoopFlow, which Dan Gordon and I worked up while we were at KubeCon. And it's just a quick little example of how to use GitLab and Kubernetes for machine learning. Now, we did this as part of trying to add some content to a workshop that was developed by AWS and that is being presented at reInvent and possibly at GitLab Commit about machine learning using CoopFlow. And so there's a focus on using Kubernetes as much as possible and also using AWS as much as possible. Not necessarily exactly how you would do it in a normal situation, but it's still a pretty good example. Now, if you're wondering what CoopFlow is, CoopFlow, the machine learning toolkit for Kubernetes, is actually a collection, it's a Helm chart with a collection of commonly used tools for machine learning that are sort of all deployed at once. It deploys dozens of containers in your Kubernetes cluster. In fact, while this project is called CoopFlow, we're not actually using CoopFlow. The only one that we're using, the only component of CoopFlow that we're using is Tensorflow. Tensorflow, of course, is the big popular machine learning toolkit in Python developed by Google. And we're using Tensorflow by pulling the Tensorflow image directly from Docker Hub the way we do other images. And so we're kind of bypassing the whole CoopFlow thing in this case. Tensorflow is used to train and run machine learning models. And in this particular case, we're going to be using a data set from a group called Keras, K-E-R-A-S, which I don't know much about. But the particular data set we're using is the Fashionista database of fashion articles. So this is 60,000 training images and 10,000 test images. This is a pretty normal way to deliver these data sets for machine learning. The idea is you use these 60,000 images to train your model, and then you use the 10,000 images to test it and see how well your model does. And basically, there are a bunch of small images that are one of these 10, each of which is one of these 10 pieces of clothing. And in fact, if you go into the repo here, you can see the little pieces of clothing here, and this kind of gives you a sense of what they are. And I'm not sure what this animation is doing, some kind of proximity analysis, I guess. So that's what we're going to be using. And it turns out that Tensorflow actually knows how to pull these training data sets, these sort of standard training data sets, automatically. So we don't even need to worry about where that's located or anything. Now, in order to run this on Kubernetes, I have to have a cluster. I used EKS for GitLab, which is the cluster setup script that I wrote way back a few months ago. Spins up a cluster on EKS and makes it available for GitLab, gives you all the information that you need to run it on GitLab. Of course, my usual day-to-day cluster is a GKE cluster, but because we were doing this example for Amazon, I wanted to make sure I had it working on the EKS cluster. In fact, I've tried it on both, and it works equally well. So it's a really great example of Kubernetes. And these are my clusters here. So you'll notice my GKE cluster is actually at the group level. This CoopFlow cluster is actually at the project level, and that's the one that's actually being used in this particular example. So one of the ways that this works is it takes advantage of the fact that when you have your Kubernetes integration in GitLab set up, you get a bunch of variables preset for you, one of which is CoopConfig, which just points to the config file for Kubernetes. Now, in order for CoopConfig to be populated, you have to use the environment label tag in your GitLab CI YAML, and that kind of populates all this stuff for the correct environment, the correct Kubernetes cluster for your particular environment. So this is an example, and the first one that I've ever done of using the Kubernetes integration without using auto DevOps. You get these environment variables assigned to you. So if we look at the project really quickly, there's not much here. The most interesting parts are the mnist.py file. This actually, we got this from the Amazon workshop. And this basically does all the processing and training using Tensorflow and pulling in that Keras file set. So I didn't really touch this very much, except just to make sure that the ArgParse stuff was working right. Otherwise, this is exactly how it came from Amazon. The other Python file here is the Inference client, which is an even shorter file. And this is the thing that actually takes the model once we've trained it and returns a value when you give it an image. So this is just one call. This could almost be used in a serverless type of environment. The other files that are in here, besides the GitLab CI YAML and the Dockerfile, are these minced training and minced inference files. These are Kubernetes config files that allow us to actually set this up in Kubernetes. So we're actually going to be doing two things in Kubernetes. The first thing we're going to be doing is training. The second thing we're going to be doing is inference. Now, you could do the training on the runner or in another environment. In fact, because this isn't really parallelizing that training at all, I don't know that we're really getting a lot of benefit out of running it on Kubernetes other than we're just showing that it could run on Kubernetes. And I did actually create a job that does the training directly on the GitLab runner, which is pretty cool. But this is doing the training. One of the things you'll notice is that I'm not using the K8s secrets thingy to pass my Kubernetes secrets down into my Kubernetes cluster. This is partly because I wanted to keep these variable names really simple in the GitLab configuration, so that if we're doing this as a workshop for AWS folks, we don't have to be teaching them about K8s_secret. They can just use the normal environment variable names the way they like it. And so we just pass through the ones that we need. That feels a little safer to me than using the K8s secret stuff anyway. So that one's for training. There's another one for the inference client. The inference client actually runs as a service. So it needs a, it needs a service and a deployment. And there we go. Minced inference.yaml. Once again, this basically came from AWS. We did very little tweaking on this. There were only a couple little things I had to tweak. The main one of which was removing the namespace label, because of course GitLab assigns namespaces itself. So otherwise, this is pretty much directly what we got from Amazon. So for the most part, we're just taking the content from this Amazon AWS workshop and running it in GitLab. Now, I've also got a Dockerfile here. It's really simple. But basically, it's just taking the TensorFlow image and adding in these two Python files. One is called main.py. The other one is called minced.py. And that just allows us to put all this in one container with TensorFlow that we can run directly on our cluster. Main.py doesn't really do anything very much other than just make sure the credentials are all set up right, the buckets are set up, and then run the main function from the MNIST file. So this is sort of like GitLabifying the thing that came from Amazon so that it's kind of in a separate place. Looking really quickly at our CI YAML, I defined 6 stages. The first stage is validate. I'm actually skipping that right now. What that does is it runs a version of the TensorFlow that trains and then outputs the result of the test immediately. So it's not generating a model and storing it. It's simply just validating that you're getting a number back out of it. And we'll see that number anyway. I left that job in there just in case it was useful. There's also a job here that's also not running, notice the dot, to train on the runner. So this actually pulls the TensorFlow image on the runner directly from Docker Hub, and then just runs the Python to train the model, and then drops the model in a model folder. This was also kind of a first attempt just to make sure that it would work. I just left it there just for historical purposes. The stuff that actually runs, first build the Docker container for the model. This is just doing a Docker build and then pushing it to my registry. And in fact, I have my registry. I go there. And you can actually see that here is the Docker container, which is essentially, if you remember, the Docker file is just TensorFlow plus the Python files. So that's in my registry. Then there's train on Kubernetes, which does the training. I just pulled Ubuntu here, and then I'm installing essentially kubeCuddle and msubst. This is just a trick for shoving your environment variables into your YAML, which seemed really handy, so I went ahead and used it. All this blob is doing is installing that stuff and getting it right. So essentially, you're taking that Kubernetes YAML and passing it to kubeCuddle is all you're doing to kick off that training. Now, you'll note that you could have a race condition here because this is going to return and finish before the training's done. The job is going to finish before the training's done. So if your runners are faster than your training, then you'd have to wait for it to finish. That's just a simplifying assumption here. Then once that's done, you do the inference pod. So this is a separate pod, which is going to actually perform the inference. And it's actually going to pull the trained model is stored in an S3 bucket, and then the deploy job actually pulls it from the S3 bucket. Not sure I would necessarily use an S3 bucket under normal circumstances, but since we're doing this, we're setting this up for AWS, we did that. So once again, it's an msubs command, the exact same before script as before. Obviously, that could be made more efficient there. Then there's a test. This is pretty cool. This actually just does it's a random sample of the test data subset and throws it up there and then returns the results. So it's actually kind of confirming that your inference engine is running, that it's responding on the correct port, that you can hit it, and actually gets a response back. And it's random, it's non-deterministic, so it's not necessarily a thorough test, but it's kind of the way that they normally test this, and it's built into the Python script to be able to do that. Also, I used a slightly different way of installing Cuddle here, which is a little inconsistent, but whatever. Then finally, there's some cleanup. This isn't really very stable in the sense that it creates the training pod, it creates the inference pod, and then it puts the model of the trained model on S3. All of that has to be removed in order to run it again. And so this job cleans up the training pod. This job cleans up the inference pod by just using kubectl delete. And this cleans up the S3 bucket just by using AWS S3 RM. So what does this all look like when it runs, you're wondering? Well, it runs and it works. And so real quickly, if we do the build job, like we noted, is just creating the Docker container and putting it on the registry. So that seems to have worked. And then it got trained in Kubernetes and got put into the S3 bucket. And so there's actually a model in the S3 bucket after this runs. But notice all this really does is create the pod and get it started. So that then ran, although it runs quickly enough that there was no race condition. Then there's the deploy job to actually deploy the inference engine to another pod. By the way, the inference engine pulls the model from S3 in real time. So in fact, you don't need to start the inference engine every time you do the training. Probably if I was going into production, I would architect this pretty differently, but we wanted to kind of encapsulate everything all in one pipeline. And then finally, here's the test, which you'll see here. This is pretty cool. It has randomly selected an image. It sent the image to my inference engine, and then it says the model thought this was a sandal, and it was actually a sandal. So the model got it right. And then there's, of course, the cleanup jobs here. So very, very simple example of how to do machine learning in Kubernetes using GitLab on AWS. What I like about this is that there's a little bit of a story here about machine learning, which I haven't really had until now. And also kind of a great example of how the Kubernetes integration works, the Docker registry, variables in GitLab, GitLab CI, and kind of getting it all working together. Thanks a bunch to Dan Gordon for helping out with this. And thank you for watching this somewhat long recording, which I now need to